In this video we are looking at quadratic functions. Quadratic functions are the type that have an equation in the form of ax squared plus bx plus c, and that's generally either set equal to y or set equal to 0. So for now we'll say it's set equal to y. In a little bit we may have some set equal to 0. Notice that if we took this x squared term away, this would look much like a line, bx plus c. But since we have the squared term in it, it's going to do some different things to our data, so that's going to give us a different type of graph. What we want to look at first is just some basics about a parabola. The shape itself looks like this, and this is probably your most standard parabola. Down here at the very tip, the little turnaround point, that would be called the vertex. And for this one, since it's the lowest point on the parabola, it would also be called a minimum. If I was looking at a parabola that was facing downwards, or opening downwards, the highest point would be its vertex. And since it is the highest point, it would be known as the maximum. This vertex lies on an imaginary line that runs down the center of the parabola. We'll kind of sketch it in here so you can see it. That would be called the axis of symmetry. And the reason it's called the axis of symmetry is because if we fold it over at that point, or at that line, we fold it over, both sides of the parabola should look exactly the same, which is where we get our symmetry. So this line is our axis of symmetry. Since our parabola is facing upward, this line that runs down in between it is going to be a vertical line, so it's going to be one of those that has x equals some number, whatever the number happens to be. Same thing is going to happen if our parabola is facing downward. We're going to have this axis of symmetry, and it's going to have a vertical line that runs through it, and it's also looking like x equals a number. One of the ways that this axis of symmetry is helpful for us is because we know this vertex always lies on it. When I have x equals some number, that x number is also the x value of the vertex. We can find this axis of symmetry using the equation x equals negative b over 2a, and those letters are referring to what we have as coefficients up here in our equation for a and b. So let's give ourselves an example. Say I have a graph here, and I want to come up with some points for the equation y equals x squared. And we'll just start with this one since it's the most basic one. For this one, I'll create a little table over here. And we're just going to put some numbers in. I'm going to start with 0. If I throw in 0 and square it, I'm going to get out a 0. So I have the point 0, 0. If I throw in the number 1, 1 squared would be 1. So I would get out the point 1. If I put in the point 2, 2 squared would be 2. Sorry, 2 squared would be 4. So I would have the point 24. And then at negative 1 squared would give us a 1. So negative 1, 1. And then if I put in a negative 2 squared would give me positive 4. So negative 2, 4. And we would start building our parabola this way. Something like that. So now that I'm looking at that, I want to see what this axis of symmetry is. Now I should be able to tell just from my drawing that the axis of symmetry is going to be exactly on the y-axis. If this is my x-axis, this is my y-axis. So my y-axis also has another name. It's a vertical line at x equals 0, because all of the points on this line have an x of 0. This point would be 0, 1, this would be 0, 2, this would be 0, 3, 0, 4, and so on. Now, if I was looking at my equation, it's in the form of y equals 1 x squared. Remember, there's a 1 there whether we see it or not. We don't have any terms after that, so it's kind of like we have a 0x and just a 0 at the end if we were putting it in ax squared plus bx plus c form. So, say I wanted to find my axis of symmetry and I couldn't just look at it. I would use the equation x equals negative b over 2 times a. So if I put those numbers in, negative b would be negative 0 over 2 times a, which is 2 times 1. So I have negative 0, which is just 0 over 2, which reduces to 0. So I have the equation x equals 0 for my axis of symmetry. Let's try another one. For our next example, let's just give ourselves an equation. We'll use y equals x squared plus 6x plus 8. Something like that. If I wanted to kind of predict ahead of time what my parabola would look like, there are some indicators that happen along this equation. One of the most important is looking at the x squared term. If this is a positive, then our parabola is going to be facing upwards, which means it's going to have a minimum point, so a minimum vertex point. I can also kind of identify where my axis of symmetry is going to be. So before I start, my A is 1, my B is 6, and C is 8. So if I wanted to find my axis of symmetry, I would use my x equals negative b over 2a formula. So I have x equals negative, and our b was 6, over 2 times a, our a is 1. So I have negative 6 over 2, which reduces to negative 3. So I have x equals negative 3. So on this one, the axis of symmetry is at x equals negative 3. So we're going to draw an imaginary line at negative 3. And somewhere along this line is where our vertex shows up. So how could we find our vertex? Well, we're going to take that negative 3 and we're going to put it in place of x to see what we would get out for y. So we would put in negative 3. So here we have negative 3 squared, which is 9. 6 times negative 3, which is negative 18, plus 8. We have 9 minus 18, which is negative 9, plus 8, which gives us a negative 1. So when we threw in a negative 3 for our domain, we got out a negative 1 for our range. So our vertex point is at negative 3, negative 1. So we go over here to negative 3, and down to negative 1, and put our vertex point. Now, to find other points, we just need to plug in other values. So we could create a table to keep track of those values. We know our vertex point, or our midpoint, is at negative 3, negative 1, so we want to pick some x values on each side of that. I'm going to choose negative 4 and negative 5, and negative 2 and negative 1. So we're going to throw these values in. Now, if you're wanting to have a shortcut to get these points, as opposed to throwing them in every time into our function machine and getting out a y value, what you could also do is go to your calculator and type in your equation in the y equals section, and then go over to your table. Remember, your table is at second and the graph button. So we'll go ahead and throw these in real quick. We have negative 5 squared, which will give us 25. And then 6 times negative 5, which would be negative 30. And then we have a plus 8 at the end. So if we simplify that, we have 8 and 25, which would be 33, minus 30, which would give us a 3. We'll do the same thing for the negative 4. If I throw in 4, or negative 4, I have negative 4 squared, which is 16. I have negative 4 times 6, which is negative 24. And at the end, I just have a plus 8. So 16 and 8 is 24. Minus 24 would give me 0. Now I would expect to have a 0 here and a 3 here so that I have the same pattern on both sides of the graph, on both sides of the vertex. So here when I throw in a -2, I'm expecting to end up with a 0. So I'll throw in a -2. I get -2 and square it, which would be 4. And I have -2 times 6, which is -12. And then of course we have our plus 8. 8 and 4 gives us 12, minus 12, which is 0. So we did get the 0 that we expected. For the -1, when I throw it in, I'm expecting to get out a 3, just like I did when I threw in the -5. So I have -1 squared, which is 1, plus 6 times -1, which is -6, and then a plus 8. So 8 plus 1 is 9 minus 6, which is 3. So once again, I got what I expected. Now we're going to go graph those points, so we have our parabola starting to take form. We have -5, 3. 1, 2, 3, 4, 5. 1, 2, 3. We also have a point at -4, 0. We have another point at -2, 0. And at -1, 3. We'll go ahead and draw our smooth curve. Remember, the lowest point on our parabola is our vertex point. This one happens to be a minimum. And it shows that our point is on the axis of symmetry. Our vertex point is on the axis of symmetry. Notice the vertex has an x value of -3, and our axis of symmetry is x equals -3.